In example 5, we're going to see that ambiguous case now that has two different solutions. It says, consider a triangle ABC. Suppose that A is 43 degrees, A is 25, and B is 28. Solve the triangle. Carry your intermediate computations to at least 4 decimal places and round your answers to the nearest tenth. So let's create our triangle first. So here's A, here's B, and here's C. A is 43 degrees. Little a is 25, and little b is 28. So the first thing that we want to do here is we want to find our angle B, because again, that's the angle that has the side across from it. So to find angle B, we're using angle A and side A with our law of sines, and we get the sine of 43 degrees over 25 equal to the sine of B over 28. And then what we're going to do is we're going to cross multiply. So we have 28 times the sine of 43 degrees equal to 25 times the sine of B. And then we have to divide both sides by 25. So we have 28 times the sine of 43 degrees over 25 equal to the sine of B. And then finally, with the sine of B, we need to go ahead and take the inverse of both sides. So we're going to do the sine inverse of 28 times the sine of 43 degrees over 25 equal to B. And then what we want to do is we want to plug that in our calculator, and we're going to round that to the, so in this part of our problem it says carry your intermediate computations to at least 4 decimal places. So we're going to round this right now to the nearest degree. And if we plug that in, we should get B to be approximately 50 degrees. Make sure you check that on your calculator and you agree with the same thing and that you know how to plug it in the right way. I'm going to label that on my triangle just so I have it here. B is going to be 50. Then the next thing that we can find is we should be able to find angle C because we have 2 out of the 3 triangles. So to find angle C, we're just taking 180 minus 43 and then minus 50, which will give us an angle measure of 87 degrees. So angle C is going to be equal to 87 degrees. So here's angle C, here's angle B. So let's put that in our triangle, so that's going to be 87. And then the last thing that we need to find here is we need to find side little c. So we're going to go ahead and do that. So to find little c, we need to go ahead and use angle C that we found, and then again I would use A. So we have the sine of 43 degrees over 25 equal to the sine of 87 degrees, which is our C, over little c. So we took the sine, the angle on the side here for A, and then C, that's our angle and that's our unknown, which is right here. So to solve for C, we would first have to cross multiply, and we get C times the sine of 43 degrees equal to 25 times the sine of 87 degrees. And then we just have to divide both sides by the sine of 43 degrees. So C is going to be approximately, so again, you're taking 25 sine of 87 degrees and dividing it by sine of 43 degrees. Try that on your calculator. And what we should get for C is about 36.6 if we round it to the nearest tenth. And that is going to be triangle number 1. So let's write that answer out right now, and then we'll check to see if we have a second triangle. So triangle number 1, we know that angle B is going to be approximately 50 degrees. We know that angle C is approximately 87 degrees. And we know that little c is approximately 36.6. Then what we need to do, since this is a side-side angle problem, is we have to determine if a second triangle exists. Now, to figure out if the second triangle exists, so let's write that down. Check if second triangle exists. If we think about the first angle we found angle B to be 50 degrees. Now remember the sine function, so just a quick check. If I'm looking at the sine function, remember sine is positive in both the first and the second quadrant. So the sine of 50 degrees and the sine of something else in the second quadrant is going to be the same value. So what we're going to do is we're going to take another option for 50 degrees. So we want 180 minus 50 degrees. So we take 180 minus 50, which would give us 130 degrees. And so we're going to check to see if 130 degrees will work. So we're going to create another triangle. This would be, again, A, B, and C. And instead of B being 50 degrees, we're thinking that B might be 130 degrees. A still has to be the same thing, which was 43 degrees. And what we need to determine is, can we get an angle C? Can we get three things to add up to 180 without going over that number? So we're going to take 180 minus 130 minus 43, and you should see that we do get angle C to be 7 degrees. So right now we have a second triangle. We know angle B is equal to 130 degrees, and we know angle C is equal to 7 degrees. And then we need to go ahead and find side C. So our original triangle, those still are the same. This is still 25. We still know B is 28, and so we need to find little c. To find little c, we're going to go ahead and use our law of sines. So starting with A's, we got sine of 43 degrees over side A, which is 25. And that's going to equal sine of 7 degrees over little c. Cross multiply, we get c times the sine of 43 degrees equal to 25 times the sine of 7 degrees. And our last step is to just divide by the sine of 43 degrees. Again, I would pause it, plug that in your calculator, make sure you agree with what I've gotten, and that you can plug it into your calculator the right way. And we get c to be about 4.5. So for our second triangle, so we have a second answer here. So triangle number 2, we know that angle B is 130 degrees, angle C is 7 degrees, and side C is approximately 4.5. So we have two answers. We have this one, and we have this one up here, which is triangle number 1. So both answers you would put down as the correct one. If you have questions, let me know. Otherwise, you can go ahead and get started on your homework.